Hello, it's Pre-Calc lesson 86, arithmetic progressions and arithmetic means. So this is referring to sequences and progressions. Can we see that? Let's do black. So a sequence is from the Latin word to follow, and it is we have finite sequences, which are sequences that have finite number of members. Now a progression is from the Latin word meaning to go forward. Okay, and in math it is used to describe a sequence in which each term depends on the preceding or the term before the preceding term. Okay, so arithmetic progressions and means is an arithmetic sequence. Okay, and it's formed by choosing the first term, and then adding a constant to form the succeeding terms or the following terms. The constant we call the common difference. All right, now arithmetic means it's all the terms between the first and the last, and this only applies to finite sequences. So what does all of this mean? If we were to have an equation, the nth term, so a sub n being the nth term, is a sub 1, our first term, plus n minus 1, n being the number of terms that we had, times d. d is our common difference. So let's do an example. Example 1, write the first 4 terms of an arithmetic sequence whose first term is negative 14 and the common difference is 10. So our formula, a sub n is a sub 1 plus n minus 1 excuse me, times d. Okay, so our first term is negative 14. They give it to us. Our second term, a sub 2, okay, is we have negative 14, which is our first term, plus n, which is 2, minus 1, times my common difference, which is 10. So this gives me negative 14 plus 10, which is negative 4. My third term, a sub 3, I have a sub 1, plus n, which is 3, minus 1, times 10. So this gives me negative 14 plus 2 times 10, negative 14 plus 20, which gives me 6. Fourth term, a sub 4 is the first term, negative 14, plus 4 minus 1 times 10, which gives me negative 14 plus 3 times 10, which is 30, and so it gives me 16. So you write your terms. We have negative 14, comma, negative 4, comma, 6, comma, 16. Those are the first 4 terms. Okay? All that it is plugging it into this formula. Yes, you do have to memorize the formula. All right, let's do another example. Find the 25th term of an arithmetic sequence whose first term is 12 and common difference is negative 6. So we're looking for a sub 25. Yes, this is how you should write it. A sub 25 is, my first term is 12 plus n is 25 minus 1 times the common difference of negative 6. So 12 plus 24 times negative 6 gives me negative 132. That's my 25th term. All right, let's do another example. Insert 3 arithmetic. You can say arithmetic. I learned it as arithmetic, so there you go. Between 2 and negative 4. Okay, so what I'm looking for, right, so we have our first term. We want 3 arithmetic means, which is 3 terms between the first and the last. So second term, third term, fourth term. That's my 3 terms, and then this is my last term. It tells me that my first term is 2, my last term is negative 4. Okay, and I know that this second term is going to be a1 plus 2 minus 1 times d. My third term is going to be a1 plus 3 minus 1 times d. Okay, my fourth term is going to be a1 plus 4 minus 1 times d. And my fifth term is a1 plus 5 minus 1 times d. So the first thing we have to do is we have to solve for all of our parts. Now we know that a1 is 2. Okay. Now we can solve for d because we know that negative 4 is a1 plus, okay, 5 minus 1 is 4 times d. So negative 6 is 4d. So d is negative 6 over 4, which is negative 3 halves. Okay. So my second term, a sub 2, is going to be 2 plus negative 3 halves, which gives me a half. A sub 3 is going to be 2 plus 2 times negative 3 halves, which these cancel, which gives me negative 1. A sub 4 is going to be 2 plus 3 times negative 3 halves, which gives me negative 5 halves. Okay, you could write these as decimals, 0.5, negative 1, negative 2.5. That's fine. So then my 3 arithmetic terms would be 1/2, negative 1, negative 5 halves. Ta-da! Okay? All right. Let's do another example. Write the first 5 terms of a sequence where a sub 17 is negative 40 and a sub 28 is negative 73. All right, this one's a little bit trickier. We have to set up a couple equations. So a sub 17, we know, is going to be a sub 1 plus 17 minus 1, which is 16 times d, and this gives me negative 40. A sub 28 is going to be a sub 1 plus 27 times d, and it gives me negative 73. So I can just subtract these two, right? A1 minus A1 goes away. Then I will have 16 minus 27, which gives me negative 11d, equals a negative 40 minus a negative 73, gives me 33. So d is negative 3. Then I plug that in. So A1 plus 16 times negative 3 is negative 40. So A1 is negative 40 plus 16 times 3, which gives me A1 is 8. So my first 5 terms, my first term is 8. A2 is going to be 8 plus 1 times negative 3, which gives me 5. So my list, I'll start 8, 5. A3 is going to be 8 plus 2 times negative 3, which gives me 2. A4 is going to be 8 plus 3 times negative 3, which gives me negative 1. And A5 is going to be 8 plus 4 times negative 3, which gives me negative 4. Those are the first 5 terms of my sequence. All right, let's do one last example. Find the 10th term of an arithmetic sequence where the first term is 3x plus 2y and the 6th term is 8x plus 12y. Okay, so this one, again, we have to set up another equation. Now we know that a sub 10 is going to be a sub 1 plus 9 times d. Okay, now we have to find our d. Okay, so let's look at a sub 6. A sub 6 we know is a1 plus 5 times d, right? And we know that a sub 6 we have 8x plus 12y equals a sub 1 we have 3x plus 2y plus 5d. Now, we're solving for d. Don't get confused by all the other variables. We're solving for d. So I'm going to subtract 3x and 2y from both sides. So I'll get 5x plus 10y equals 5d. And divide everything by 5. So I get x plus 2y equals d. So now, go back up to A10. A10 is going to be A1 plus 9 times d. So I get 3x plus 2y plus 9x plus 18y. So A10 is 12x plus 20y. That's my 10th term. Okay, all you're doing, plugging it into the formula. Okay, that's all for lesson 86. Stay tuned for 87.